Hello guys, welcome back to Maison African Motives, still on Mathematics N4. In this platform, we shall be revising trigonometry from the question paper of August 2021, where we are given on question 2, we are not going to waste much time. We're going to quickly rush through these questions. Determine the general solution on 2.1 of sine 2x, which is equivalent to cos of x over 2. Okay, so how do we go about that typical question? Okay, guys, so on this one, we are supposed to be very, very careful enough to attempt each and every stage, or to work out each and every stage properly. We are given that the sine of 2x is equivalent to the cos of x over 2. All right. These two, they are not the same. Okay, they're actually the same in terms of the present, but in terms of the trig, they are not the same. This is sine, this is cos. Yes, they are equal in terms of the values that you're going to have. So we know that from our identities, guys, we know that cos of x, if we are given cos x, is equivalent to sine 90 degrees minus x, okay? Or we can take it from sine, the sine of x is equivalent to the cos of 90 degrees minus x. So that means sine can be changed to cos. Cos can be changed to sine. So we are going to take here, you choose which one is best, guys. Okay, so as for me, I'm just going to focus with the first trig, which is sine. So I'm going to change sine 2x the same way sine x was changed to cos. If it is x here, okay, let's write. If it is x, then here is going to be x. So if it is 2x, if we write sine 2x like this is going to be 90 minus 2x. So that means, guys, from this consideration, the sine of 2x that we see here is the same as the cos of 90 degrees minus 2x. Okay, why are we even writing in terms of cos? Okay, let me explain this, which is equal to, already on the right-hand side, we've got a cos. We leave it like that, which is cos x over 2. Okay, so the question is, why are you even changing sine to cos? What's the purpose of doing that? The reason that we have is that if we've got two trig that we have, tan of x equivalent to tan, maybe is 2 like that, or maybe it's tan 20 or whatever that we have. If this is tan and this is tan, these two are equal. So x here will be equal to this 20. So x is actually, there's no way that we're going to have another part, or maybe unless you change the 20 to another angle, which is equivalent to it. But as it seems, x will be equal to 20 direct like that. So this is the same reason that we now have the power to equate these two both. This is cos and this is cos. So we are going to equate what is affected by cos here to what is affected by cos on the other side. So that is the advantage of writing these two. If it was sine, you do the same, but here we managed to change to cos. So that's 90 degrees minus 2x is equivalent to x over 2. So that's an equation that you are now going to solve. A normal equation, just transpose. 90 degrees is equal to, if we transpose negative 2x to the right-hand side, is going to be positive 2x. That's 1 over 2 plus 2, because this is x and this is x. So you add 1 over 2 plus 2. So from your calculator, if you add 1 over 2 plus 2, that is going to be 5 over 2x. So to find x, simply divide by 5 over 2 both sides, by 5 over 2 both sides. So this can cancel. And if you divide from the calculator, 90 divided by 5 over 2, that is going to be 36 degrees. All right, so that's the value for x. So it's a solution. I wonder why they say general solution, of which is the answer is just a normal solution where x was just 36 degrees. Okay, so like I said, you could have used sine, still you're going to obtain the same answer. So what I want you guys is to revise, to work or to redo this using sine to make sure that both sides, they will contain a sign. So which means you are supposed to apply this identity here. So I want you to try and see if you're obtaining the same answer of 36. If not, then let's know on the comment section so that we can redo this question together, working with a sign so that you will see that it's one and the same thing. All right, that was question 2.1. We move on to question 2.2, where we are given to prove the identity, the following identity that we are given, and that's 5 marks. Okay, so this question paper, it had a lot of errors, but if I refer to this before we see these errors, then you say, this and that. Okay, let's see from the question we try to do this stage by stage so that we do not miss where these errors are located. So we have got sec x here minus 1 plus the other part that was tan of x, everything over sec x plus 1, which is equivalent to 2 over the cos of x. That was the question. Okay, so take note, guys, this is what we are given, and we've taken directly as it is. Okay, and that's 5 marks. Let's see if truly what they wrote there makes sense. All right. Remember, if you are to prove an identity, you are supposed to choose the side to work from. Okay, so in this case, I'm going to choose to work from the left-hand side. Where I am given a complicated, something that is complicated there. So I'm just going to add this because I've got sec here minus 1, sec here plus 1. So let's just combine, find the LCD or the LCM, which is going to be the sec of x minus 1 into the sec. Okay, all right. So that's the sec here of x minus 1 into the other bracket, which is going to be the sec of x plus 1. Okay, so what is going to happen here is, remember your division, guys. If you add, you divide the LCM, divide by the denominator here. So as we can see, sec x minus 1, sec x minus 1 will cancel, which means you remain with the sec x plus 1. But whatever that you remain with has to be multiplied to the numerator, which is tan x. So it's tan x into sec x plus 1. Okay, so guys, so you see this sec, what is it giving us now? Okay, that's a plus here. Sec of x plus 1 and sec of x plus 1, they will cancel, which means you remain with sec x minus 1, also to be multiplied with the tan of x on top there. So that's sec of x minus 1. Okay, so we can see that there is a need for us to expand the brackets. Tan is to multiply each and every term inside the bracket. So we're going to have tan of x times sec x, which is tan x, and we have got sec x, tan x times 1, which is tan of x. We move on, plus here, we do the same, tan of x and sec x, that is going to be tan x sec of x. Then we've got tan and minus 1, that's negative tan of x. So I want you guys to be with me here. Then in the denominator here, there's something that is, we can, yes, rewrite as it is, but there's something that is happening between these guys. This is a sec minus 1 plus 1. So you know that from our difference of two squares, a minus b plus a minus b, as long these two are the same, but one bracket subtracts, another adds, this was taken from a squared minus b squared. So all you need is to add these two numbers, which are the same. Sec, we square it, we also square 1, just like here, sec, and so forth. So we're going to have this as sec squared x. Okay, so that's sec squared x minus 1, from which was 1 squared, and 1 squared is what? It's 1. Or you can expand the brackets as normal, but guys, let's try to apply our identities or whatever that we know to minimize these calculations. Okay, so let's see if we've got like terms in the numerator. We've got tan x and tan x, which is going to cancel. All right, then here it's like 1 tan sec plus 1 tan sec. So if you add, it's 1 plus 1, which is 2 tan of x sec of x. So here I want you guys to be with me. Okay, this was supposed to be written as over sec squared x minus 1. I want you to be with me here. All right, from our identities, there is this identity that you are given. Let me take it from your formula so that you see where this guys are having some errors there. All right, let's see if we are given this identity. Yes, we have got it here. So we want an identity that is going to apply sec squared. Okay, here we've got our identity which is written as 1 plus tan squared x is equivalent to sec squared x. But there it was written as sec squared x minus 1. So what happened? We simply transposed 1 to the right-hand side. It became -1. So if we transpose 1 here, it means we are going to remain with tan squared. So tan squared x is equivalent to sec squared x minus 1. Take note, guys, sec squared x minus 1. That's the same as tan squared, not tan x, but tan squared x. So that means wherever you see sec squared minus 1, you substitute tan squared. So I hope you are together there. So we are going to substitute to here. That's where we are here. All right. So we are going to substitute this as 2 tan of x, sec x, everything over now the value that is going to sec, which is what? Which was tan squared x. So take note, that was tan squared, not tan x. That is the error that we are given there. All right. So in this case, we can see that we have got a tan and a tan. So one tan and another tan here. We are going to remain, because there were two. So we're going to remain with one tan. So we're going to have tan x. All right. And we know that tan is same as cot or this and that. Okay. So we can write this. I want you to be very, very careful. Let's move on together here. This was supposed to be like this. 2 sec of x over tan of x like this. Okay. But we know that sec is the same here if we are to take this sec. Okay. It was actually taken from 1 over cos of x. So that means this part is going to be 2 or 1 over cos of x like this for sec, then you multiply by 2. So if you multiply by 2, is same as 2 over cos x. So you're going to have 2 over the cos of x like this. Take note, guys, what was happening. Divided to tan, where we know that tan of x is equivalent to sine x over the cos of x. So if you divide, the moment you divide like this, we are going to introduce multiplication. But on the multiplication now, what do you do with the fraction? You invert. Remember, tan is represented with a fraction, sine over cos. So you invert the fraction when you introduce multiplication. So this is going to be cos of x on top over the sine of x. All right, so let's see what is going to happen from this. The cos and the cos is going to cancel, and that means we are going to obtain 2 times 1, because this is now 1. So 2 times 1, that's 2 over 1 times sine, which is the sine of x. Okay, this is the answer that we are obtaining after all proper or all the actual ways that we're supposed to apply. Following the actual procedure, this is the right answer that you're supposed to get. But if you are to check here, on the other side, it's given as 2 cos, which is actually wrong. So I want you to correct that even from the memo there, that was actually wrong. The proper way of identities must be applied properly, especially there where I indicated the identity that is equivalent or the answer equivalent to sec squared, which is tan squared, not tan x, but tan squared. The tan x now is after canceling these two. So that is actually wrong. So please correct that. So our answer is supposed to be 2 over sine of x, not 2 over cos x. So this was supposed to be proof that this is equal to 2 over sine x. Okay, so I hope we are together there on this part. If you've got queries there or any other explanations or any other ways that actually gave you 2 over cos, guys, feel free. Let's talk on the comment section. Let me know. Maybe you got another way which actually gave you the direct answer. That would be very, very good to hear of. Okay. On 2.3, we are asked to simplify as far as possible, as far as possible. Okay, so what do we have there? We are given to simplify. That is, I've got sine squared 180. Okay, that is another question also which had some errors there. So this question paper, it had a lot of errors. But anyways, as we revise, then we know what was supposed to be done there. Okay. So 180 plus theta is an angle that we see in the second quadrant, okay, from our identities. 180 plus theta is in the second quadrant. So from the cast concept, or from all students take calculus, sine is a positive in this quadrant. So this means this was going to be sine of theta being positive as it is, okay? So it was going to be sine of theta. But there is a squared which is there. So it is going to be sine squared theta, or you write it as sine theta like this, you square it like that, or you just write it as sine squared like that. Okay, guys, so this is sine 180 plus, not minus. That's a plus there. This is in the third quadrant. I hope someone saw this and was like, say, what is happening here? This is in the third quadrant. So this is sine 180 plus a theta here. 180 plus theta, that's the third. So sine is a negative. So I hope you're together there. All right, then we move on. Plus cos 180 minus theta. That's 180 minus theta, which is the second quadrant. So now we are back to the second quadrant. And in the second quadrant, this is the quadrant for sine. Okay, so which means cos is a negative. So this is going to give us a negative cos of theta. Be very, very careful. Okay, then we've got a sec cosec 90 minus theta. All right, we know that cosec is 1 over sine. So if it is cosec 90 minus theta like this, it was supposed to be 1 over cos 1 over sine, because this is cosec. It was supposed to be 1 over sine theta, but it is 90 minus theta, so it's going to be sine 90 degrees minus theta. But remember, we talked about 90 minus theta, that this whole part gives us a cos. So sine 90 minus theta is equivalent to cos. So this is the same as writing as 1 over cos of theta. So this is going to be times 1 over the cos of theta. Okay, everything over, that's tan 180 minus theta. Okay, we are still 180 minus theta, we are still in the second quadrant, where we said in the second quadrant is for sine. So which means tan is going to be a negative. So this is going to be negative tan theta. All right. Then tan 90 minus theta. Tan 90 minus theta, guys, you must know this is equivalent to cot theta. All right, so this is going to be cot theta. All right, so this is the stage where we are. So take note, the question is for us to just simplify. All right, so from this stage, we can note that here we can even cancel some of the things. All right, but you've got sine minus sine squared. So minus becomes a positive. So it is going to be positive sine squared theta. So you can even write as sine squared theta. All right, here it's minus cos theta, which is same as minus cos theta over 1. So cos and cos will cancel. That means we are going to be left with negative 1 and 1. So negative 1 times 1, that's negative 1. Everything over negative tan by cot. Remember that tan is the same as sine over cos. So it's sine over cos times cot, which is the same as cos over sine. So it's an advantage. Cos will cancel, sine will cancel, which means you remain with a negative. So here we are remaining with a negative. All right. Remaining with a negative means this negative is going to affect everything in the numerator. So it's negative by sine, which is negative sine squared theta. Negative by negative 1, that's positive 1. So this can be written as 1 minus sine squared theta. Take note, guys, stage by stage. But 1 minus sine squared theta, where are we going to obtain this? From our identities again, we know that cos squared theta plus sine squared theta gives us a 1. So in order for you to have 1 minus like this, it means we transpose the sine to this side and we remained with the cos squared theta, which is 1 minus sine squared theta. So wherever we see a 1 minus sine squared theta, we know that is representing cos squared. So our answer is going to be cos squared theta, which cannot be simplified any further. This cannot be simplified any further. So take note, guys, if you are revising, it's not always that the memo is correct. Look into the question again and again and again so that you understand. Because most questions, what they do, they are actually, the memos, they're actually revised as they are marking. That's when the errors are being revised. But the corrections on these memos that we have now, we do not have those corrections. Most part, if you check the previous, very previous question papers, they used to do that. But now they just give us with those questions which were not corrected. But it doesn't mean that when you have your final marks there, they will be having those errors will be no, it won't affect you guys. They know how to deal with this. Okay, on 2.4, we are now given if tan of the alpha, so that's tan alpha from 0 to 90 degrees, determine without using a calculator the value of 5, whatever that you're given there. Okay, so that's question 2.4. Just going to rewrite our question here. So on question 2.4, we are given our tan alpha as 12 over 5, okay? And it's given that this alpha is supposed to be taken from 0 to 90. That's from 0 to 90. This is the first quadrant, okay? If you are to check, guys, from your quadrants, we know that our angles, they are being taken in an anti-clockwise direction for them to be positive. Okay, guys, I'm just going to draw something that you can see because this line is becoming a challenge. Okay, something like this. So your angles, they are taken from 0 degrees, 90 degrees in that order that we have 180 and so on and so on. Okay, so this is where we have our angle. Our alpha is going to lie between 0 and 90. That's in the first quadrant. So we are going to have our triangle in the first quadrant, where we know that in the first quadrant, all the given ratios, they are actually positive. Okay, so this is our alpha here. So what can we do now on the diagram? We know that in order for us to simplify the value that we are asked here, which is 5 sine x, whatever, this is not x, but this is alpha. So this is 5 sine alpha cos alpha. Okay, so we've got 5 sine alpha. So we want to simplify, or we want to find the value of 5 sine alpha plus 12 sine of alpha. All right, was it still sine or it was now cos? That's a cos. All right, so that was cos alpha, not sine. So this is cos. All right, that's a cos here. So this is 12 cos alpha. All right, so this is what you're going to have, guys. You are supposed to indicate on your diagram so that we can find the corresponding ratio also for sine and the corresponding ratio for cos. Knowing that from our soccer tower, this is where we've got our soccer tower here. From what we are given the identity, or we are given a ratio for tan. So that means from this ratio of tan, we know that tan alpha is supposed to be equivalent to opposite over adjacent from the ratio. That's opposite over adjacent. So that means the 12 that we see here represents the opposite. The 5 that we see here represents the adjacent. So according to alpha on the diagram here, this is our alpha, this angle alpha here. Which angle is which side is opposite to alpha? So the opposite side is this side here. So that's where we are going to have the opposite, which is 12. So this side, that's 12. The adjacent, where we have 90 degrees and the angle sitting next to each other, that's the side 5. So definitely, in order for us to have cos, sine and cos, we can see that on sine, there is hypotenuse. On cos, there's also the hypotenuse. So we are now forced to calculate h, representing the hypotenuse. So from your Pythagoras theorem, we know that h is equivalent to the square root of a squared plus b squared, or you can start as h squared is equal to a squared plus b squared. So to find h, we introduce the square root. So h is equal to the square root of this shorter size, which is a and b. All right, so that's 5 squared plus b plus 12 squared, or 12 squared plus 5 squared is still one and the same thing. All right, so if we simplify, we are going to have our hypotenuse, which is h, as 13. So this side represented by h here, it's a 13, which is our hypotenuse in this case. Okay, so having this now, it is going to be easier for us to simplify the ratio or this trig, because we know that we are going to have 5 being multiplied to sine alpha, and sine alpha is opposite over hypotenuse. So which means sine alpha, if it is opposite over hypotenuse, that's the opposite is 12. According to alpha, this is the opposite. That's our adjacent, and that's our hypotenuse. So opposite, that's 12 over the hypotenuse, which is a 13. So this is the value that you are supposed to indicate in place of what? Sine alpha. That's 12 over 13. So this is going to be 12 over 13. All right, we move on to the other part of 12. So if we are taking 12 here, that's 12 cos alpha. So it's going to be plus 12 cos alpha, of which cos is adjacent over hypotenuse. So this is the adjacent, which is 5 over the hypotenuse, which is 13, like that. All right. So take note, guys, from your memos there, like I was saying, please, guys, revise so that you can also note some errors as you are just working. Okay. So anyways, this is same as 5 over 1, 12 over 1. So if you multiply 5 times 12, that's 60 over 13. 12 times 5, which is also 60 over 13. So if we add 60 plus 60, that's 120 over 13. So this is going to be the indication or the answer representing 5 sine x plus 12 cos of x. All right, so these are the typical questions, very, very typical questions, and you must be very, very careful. So revise as much as you can. So that's what we had, guys, for Meson African motifs on mathematics N4 revisions till we meet again.